Problem 3, we're solving this absolute value of x minus 1 less than 5. Let's think about the absolute value first. If you had the absolute value of x is equal to 5, let's just say it equaled 5, what would this x value be? Well, it could be the positive 5, because the absolute value of 5 is 5. But don't forget, there's also the negative component. The absolute value of negative 5 is 5. So when we do this problem, we got to consider the positive and the negative piece. We got to consider them both. So we're going to end up setting up this equation, and we're going to have to deal with the positive part of that 5 and the negative part also. The other thing we need to do is we've got to look at this sign. This absolute value piece is less than. Sounds like the word what? And. This is going to be an and situation where x has to do this and it's also going to do this. So let's take a look. So the way I'm going to start it is I'm going to look at taking the x minus 1 being positive. It's got to stay less than 5. And I'm going to look at the other piece, and I use and instead of or because it's a less than. I'm going to look at the x minus 1. I've got to look at the opposite of the x minus 1, the negative piece of it being less than 5. This is the way I like to do it. I set up the two equations. I set up the positive piece less than 5, the negative piece less than 5. Solving this side always usually pretty simple, less than 6. Now this, notice what's out here is really a negative 1. So we want to get rid of that. So the first step we're always going to do is divide by negative 1, which gets rid of it. But if you divide this side by negative 1, you have to divide this side by negative 1. So we now have x minus 1. What happens to the symbol? Well, when you divide both sides by a negative, the inequality flips. Again, you can watch. I've talked to you all about that and explained why. If you need to see a video on it, hopefully I'll put a little video spot here that you can just click on and do. 5 divided by negative 1. 5 divided by negative 1 is negative 5. Add 1, add 1. X must stay bigger than negative 4. So x is going to be less than 6, and at the same time it's got to stay bigger than negative 4. Now I don't want you to come in here and say, oh, what's that and that. We got to put this together. We got to think this through. I want x to be bigger than negative 4 and at the same time smaller than 6. The way we write that is here's negative 4, here's 6. I want it bigger than that. So x has got to be bigger than that negative 4. See, x bigger than that negative 4. Okay, x is bigger than the negative 4. Yet at the same time, it stays smaller than 6. The solution is this inequality right here. If you do a number line, it goes from negative 4 to positive 6. It's everybody in between. And so that's what we sort of have written right here. X is between negative 4 and 6. We pick 0. 0 minus 1 is negative 1. Absolute value of negative 1, yeah, is 1. 1's less than 5. That's what's going to happen. As long as you're below 6 yet bigger than negative 4, you're going to be a solution to this problem here, to this absolute value inequality problem. So this is how I want you to write your solution. You don't need to do the graph. The graph might help you see it. This is what we should write on problem number 3.